Okay, hello everyone. So I will give you a short introduction to this vitamin week, something about this analytical methods of vitamins, and also I'm asking you to consider what should be done during the extraction and sample preparation. So I give you this material already. There's a few reviews about this vitamin analysis and also the FDA, Food and Drug Administration report on nutrient analysis. So read that paper only for those chapters or pages when it is dealing with the vitamin analysis. And then on the next part of this, I gave you some different methods: chromatography, microbiological assay versus immunoassay versus spectroscopy. And here is something about your reading about this microbiological assay, vitamin analysis using a spectroscopic method. And here's also an example of this ELISA method for vitamin B12, ELISA, which is immunoassay or immunolinked or enzyme linked immunoassay is the proper word. Yeah, ELISA. So what I'm asking you to do in then your group works, I will divide you into 3 groups, and each group will deal with one of these topics. The group 1, microbiological and biological assays, how the vitamins can be analyzed. Is there any limitations or advantages using a microbiological or biological assay? What about chromatographic assay? And the third group is then focusing on the chemical and spectroscopic methods and ELISA method and immunomethod and so on. So 3 different points: microbiological or biological assay, chromatographic assay, and chemical spectroscopy, so-called other techniques. So I will now share for you this whiteboard, and I'm now writing you something, or I try to raise your ideas a little bit about this vitamin analysis. Let's see how I'm able to work this. Okay, let's start this. So this week's topic is vitamin analysis. And let's put it also with methods. Yeah. So what are these analytical methods we can use? Let's put a little bit. So we can divide them with this kind of classification. Let's say that we can have this chromatography. What about this microbiological assay? And the third one might be these, let's say, chemical. And those, you can include there also this, let's say, spectroscopy. And for instance, direct fluorometry just as an example. What else can be included here? Let's say these different immunoassays. Sorry, immuno. So this is like the 3 different categories. Let's say that you have a chromatography, microbiological assay, and then like the others. So what is the idea here? Let's say chromatography. You are doing the chromatographic separation. In microbiological assay, you're looking for different physiological response of that specific vitamin with a certain organic, is it the microbes, or is it a mammal, or is it a cell culture or something? But let's say that's a physiological response. And in chemical methods, what you are actually looking for, you're looking for different chemical or physicochemical characteristics. Yeah. So you have different kind of procedures: chromatography, microbiological assay, chemical methods. So what are you then looking for? You are trying to find the answer with these methods, or these methods, or these methods. What is vitamin? How do you define that? You can make here chemical definition, you have certain chemical structure, or in chromatography you can separate different compounds. So is that vitamin? Or you have this physiological response. And now you have to ask, physiological response for whom? Let's continue this one. Is this compound or group of compounds chemical substances? Do they have biological response? And if they have, then you need to ask, what is the target animal or organism? So is it a vitamin for microbes? Let's say lactic acid bacteria. Or is it a cell culture? Is the human? Or is it something else? So you actually are raised the question, which is the very same that this Casimir Funk asked 1912. What is a vitamin? How do I define it? So first vitamin which was found, vitamin B1, which is thiamine. So where this name came? Casimir Funk was talking about vital amines. So this, let's see what is the structure of that. I have it somewhere here. No, this one. So this was Casimir Funk's idea that the first vitamin or compound which was named as vitamin, it was actually vital amine. And the point was that the first compound which have classified as a vitamin, it actually have this amino group. It was an amine. And because they didn't know what the compound is, they just found it's an amine, and they think that it's very, very important. So that was named as vital amine. And then that's a B1, first one. And that was how we got this name vitamin. We have this quite similar things also with, let's say, ascorbic acid. And I have my structure. I have the structure here. So when this ascorbic acid was actually found, so it was noticed in a very practical way that this compound is able to prevent and also treat the scurvy. So it was ascorbic. It was named as anti-scurvy compound. Then let's say what we else have. We might wonder what is vitamin D, let's say D3, which is now cholecalciferol. And let's take a look of the structure. It's here. And again, if you take a look of those different molecules, they have completely different chemical structures. And you can wonder that do they have also very, very different chemical behavior or chemical characteristics. So this is like a steroid. It's actually acting more as a hormone. It's very, very polar, non-polar one, sorry, very non-polar. So that's a fat soluble. Then we have ascorbic acid, which is like, it can be classified as a carbohydrate. So it's very, very hydrophilic one, but it has also the acid characteristic. We can't see it, or maybe you don't right away see it because this is now the ketoenol form. And then we have this thiamine, which has very interesting molecule. We have here nitrogen, we have here amine group, we have here charged nitrogen. It's 1, 2, 3, 4 bonds in one nitrogen. We have always a charge here. So if we now go back to this chemical characterization. So they have nothing in common. This is an amine. This is an acid. This is a fat soluble one. So that means that our chemical definition is not giving the answer. What is a vitamin? So my favorite thesis is that give me a molecule and I can analyze it, but I don't know if it's vitamin. So measuring is not difficult. We can measure with different analytical methods. We can have very, very nice instrumentation today, but this chemical analysis doesn't give us the information. Is that a vitamin or not? So this makes it quite complicated to say what is a good method. So the ISO 17025 standard says the method should fit for purpose. It doesn't say you have to use chromatography. It doesn't say you have to have immunoassay or something. The method should fit for purpose. And this is now your academic skill to find out whether this method is capable of doing this and that. And the first thing is, what is your question? Am I looking for just certain molecule like this thiamine or this ascorbic acid, or am I measuring the physiological vitamin activity? And now, if we are talking about then this, let's take another color. If we are talking about this vitamin activity, okay, what about vitamin C? Human needs vitamin C, and the other mammals, not all the other mammals. Let's say apes, and we do, but for instance, dogs are probably not. They don't need that into their diet. On the other hand, guinea pig or some hamsters, marsut, they need this vitamin C. Let's say vitamin B12. We have actually chromatographic system. We can measure two different compounds. This is now the B12, and this is a pseudo form. These both compounds, this B12 and its pseudo form, they are both used by lactic acid bacteria, but not humans. Now the point is, if we are not able to separate those two things, and we are analyzing it, let's say using microbiological assay, the microbiological assay is giving the sum of this B12 and its pseudo form, but this one is not valid for human physiology, so we are then overestimating the result. What about vitamin? Vitamin where? Are you measuring the certain compounds which are present in foods? Or in your body? Let's say that in foods, vitamin D might be in the form of cholecalciferol. But if we are going to analyze your plasma, you won't find this cholecalciferol because it has been already gone through these physiological processes and it's metabolized. And they are very often hydroxylated. One hydroxyl group, two hydroxyl group, or something else. So now you're asking, what is vitamin? In the food, it might be this form, but in your body, it has already been converted. And then finally, I will mix you now totally. Let's say that we have this food matrix. And then we have vitamin. You have to ask, in which form it is present. And I give you example, let's say niacin. So niacin deficiency was not found in Mesoamerica. Why? One of their staple food was corn. And in corn, this niacin is in the bound form. That means that if you consume corn as such, so let's say you want to cook it or broil it, majority of the niacin activity is then in the bound form. But Mesoamericans, their traditional way how to prepare food is an alkaline treatment. So they actually took this, is it hardwood ash, lehtipuun tuhkaa, they were soaking the corn material in the alkaline medium or liquid, and they actually release this free niacin from the bound form. And what was the result? Vitamin deficiency was never found in the population. So this is now like an introduction to your vitamin work. So you have to consider different procedures. How do I analyze it? But the very first question is, what is the vitamin? So this one here. What is the chemical form you are actually hunting for? And then when you know that, then you can wonder, do I need this chromatography? Or is it possible that I use some chemical analysis? Is there any chemical reaction or spectroscopy like direct fluorometry, which might be suitable for analyzing that compound? Or do I have to take this microbiological assay? Because then I know that if this microbe is growing and it's using this vitamin as one of the growth factor, so then it is vitamin. But now there is this hidden step. Is the microbe or is the animal of your experiment, is it working in the same way that is happening in the human body? Can you do any experiment with humans? Yes and no. Theoretically, yes, but practically, no. They are so time consuming. They are so tedious. You need this ethnic evaluation first. So I would say that human experiments are not possible. So you have left what you have left. You have is chromatography, microbiological, and chemical, immunochemical, immunomethods, chemical methods, spectroscopic methods, and so on. So this is now your topic, and I will divide you into 3 different groups. One is dealing with this chromatography, one is dealing with this microbiological assay, and one is taking the rest of the chemical spectroscopic immunoassays, and then try to figure out what are the advantages, what are the good points. Okay, this is good for that, but we are missing that information. Oh, this is now what we don't get. This is the information we don't get with this method part. So let's go not into the details that vitamin B1 is analyzed in this method and vitamin B2 with that method, because that is a never-ending story. Let's take these 3 main categories: chromatography, microbiological or biological assay, and others. So I hope you got something to drink, something to in your mind, that you are not completely lost after my presentation lecture. So this is very nice topic. That was something that I was also discussing in my PhD work and in my PhD lecture. What is a vitamin? How do we define it? And I would say that I'm more or less chemist. Give me the molecule and I will analyze it. But I don't know whether it's vitamin or not. So happy group work and see you. Bye-bye.